Hello everyone. Welcome to the solution of LeetCode problem 463 named island perimeter. In this problem, we are given a row by column grid representing a map where if the element is I, that represents land, and if the element is 0, that represents water. Now, grid cells are connected horizontally or vertically, not diagonally. That means the grid are connected in the 4 direction, not in the 8 direction. And the grid is completely surrounded by water, and there is exactly one island. That means one or more connected land cell. So here we have to determine the perimeter of this island. Now let's consider this example 1. Here we can see that the perimeter is the length of the surrounded region. So here we can see that this color, this darkish color is the island, and this yellow color is the perimeter. And the length of each of this yellow bar is equal to 1. So there are in total 16 yellow bar. So here we can say that the perimeter is 16. I hope you understood the problem statement. Now let's move on to the algorithm. Now here, to understand the algorithm, we have taken the similar example. Here, these cells are represented by the land, and this cell equal to 0 represents by the water. So here we can see that this region of the cell is land and the other portion is water. So in total there are 16 bar. It is one bar, it is another bar. So in total there are 16 bar. So the problem is, how can we basically solve this problem? The problem can be easily solved by using the DFS in the two-dimensional grid. Now, initially, as we are given a 2D matrix, so if we find any of the one, we will start the DFS call into its 4 direction. Suppose for this one, we can go to this cell, this upward and downward. And similarly, we will visit all of the land cell. But the question is, how can we determine the perimeter? The intuition is very simple. Listen carefully. Suppose for this land cell, currently we have in this cell in our DFS call. So from here, we can go either right, up, down, or left. Now, if our next cell is out of the bound or out of the region, in those cases, we can say that there will be a bar, or we can consider this as one of the length of the parameter. It is another case. And if the next element is 0, that means it is equal to the water cell. That means it is also a perimeter. And this is the basic intuition. Here, for each of the cell, if the next cell is either out of bound or either water cell, in this case, we can consider the respective boundary as one unit parameter. And similarly, we will do so for each of the cell. Now let's write down the example using the BFS. Initially, we are at this node. We cannot start the DFS here. We are at this node. We can start the DFS. From here, we can go up, right, left, or down. So here, for the up, it is out of bound. So this can be, or this green cell can be one of the parameter. Now for the right side, it is 0. So it can be another parameter. And the left side, it is also 0, so it is another parameter. Now, we cannot go up, left, or right because it does not have any of the cell equal to 1. So we will make the cell visited and make it 2. Now, we are at this down cell, which is 1. So for this down cell, we can go either left, right, up, and down. But all of them has land. So we cannot consider these 4 bar or these 4 region as the part of the perimeter. So we have to simply make this 1 equal to 2. Now suppose we are at this point 1. So from this 1, we can go either up, right, down, and left. So here for the up, there is a value equal to 0. So we can make it a perimeter. For the left, it is becoming out of bound. So we can make it as a perimeter. For the down, the cell is 0, which is water. We can make it as a parameter. Now from 2, we can go down. But it has 1, so we cannot make this as the perimeter. Now we are at this 1. So from this 1, we can go 4 direction, but in the 3 direction, it has 0. So we can make this as one of the side of the perimeter. This can one of the side of the perimeter, and this can one of the side of the perimeter. Now we are at this node 1, and from here we can go left, right, up, and down. In the left and right portion, we have both of the 0. So we can consider this as the perimeter. And from here we can go down. Before that, we have to make all of them equal to 2. Now from this 1, we can go either left, right, up, and down. So for this down, it will become out of bound. So we can consider it as one of the perimeter. For the right, it is the cell is equal to 0. So we can consider it as a perimeter. For left, it is 1. So we cannot consider it as perimeter. Now we have to recursively call the DFS function into this 1 and make it equal to 2. Its up cell is equal to 0. So we can make it as a parameter. Its left and down cell is out of bound. So we can make these 2 bar as the perimeter. So here we can see that in total there are 16 number of 1 unit bar we have used. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So we can say that by using the DFS in the 2-dimensional grid, we can find the perimeter of this region is equal to 16. And overall time complexity of this algorithm is big O of n into m, where n is the number of row and m is the number of column in this 2-dimensional grid. I hope you understood the algorithm. Now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a function named island parameter, which has a 2-dimensional grid named grid, and we are initializing 3 of the variable answer n and m equal to 0, and n is the number of row and m is the number of column in this grid. Now we are running a nested loop, and if the corresponding cell is equal to 1, that means we have to start the DFS, and inside the DFS we will calculate the parameter. So we have to simply break it. Finally return the answer. And inside the DFS function, if the current I or j is less than 0, or I is greater than or equal to m, or j is greater than or equal to m, or grid of ij is equal to 2, or grid of ij is equal to 0, 2 means it is already visited, and 0 means it has a water. And if this is the case, we have to return. But before return, we have to check whether current I or j becomes out of bound, or the current grid element is equal to 0. If any of the conditions is true, we have to increment the answer because this side can be a part of one of the perimeter in this island. Finally, if we have passed this if statement, we have to make the cell visited. That means we have to initialize the grid element with 2 and recursively call the DFS function into 4 of its direction, which is I plus 1j, I minus 1j, ij plus 1 and ij minus 1. Finally, we have to return the answer. I hope you understood the code. Thank you everyone for watching the video. We will get back soon with another LeetCode solution.